So here's a pattern. See if I can figure out. Yeah. Um, okay, we'll keep it easy. So here's a pattern going on, right? Can you see the pattern yet? Whoops. That's not supposed to be a 2. So you say add 3, add 5, add 7, add 9. Can anybody else see another pattern? You're right, add 11, add 13, but is there another pattern? That works. You're right, too. Because now I'll, whoops. Another pattern would be this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so forth, right? This is the first term. They use the notation A1. So A1 stands for first term. What does the little A0 stand for? You hardly will ever see it. It's like the 0th term. So you don't see it very much. Or you'll also see it as like the original term or so A1's the first term, A2 is the second term, and so forth. Does that make sense? Now here's AN is going to be the general equation to find a term. And I don't know if we'll get into this one. We probably won't get into it today, but there's one that's called recursive. It means it reoccurs, but it has an AN. For example, it's something like this, 3 plus AN minus 1. So this N minus 1 thing means it's the term before the term that you're after. So for example, if I wanted to find A3, this would be 3 plus, the second term. So that's a recursive formula because you're using the term before to generate the next term. Okay. Whereas most of the time, like this top one, I could write this formula as just AN equals. So see how this is 1, 2, 3, 4, 5. This is my first term, second term, third term, fourth term. The formula for this would be like A1 was just 1 squared, right? A2 was 2 squared. So in this case, AN equals N squared. Okay. Or if you use these numbers down here, then it gets more challenging. Then it's really weird. Let's see. I came up with this formula once. AN equals I think we did 2 times N. This was the first term, second term, third term, fourth term, fifth term was right there. So 2 times, like these are counting by odds, 1, 3, 5, 7, 9, right? 11, 13, 15. So 2 times N would be 2, 4, 6, 8, 10. Does that make sense? So I'm replacing N with 1, 2, 3, 4, So 2 times 4 would be 8, 2 times 5 would be 10. But I'm not adding evens, I'm adding the odds. So it's 2n minus 1 that we're adding each time. Because that's how you make it an odd, is you minus 1 or you add 1 from it. Minusing 1 will give you 1, 3, 5, 7, 9. So that generates the odds. So that's what we added each time. Plus the term. So like on the second term, we added 3 to the first term, right? So it'd say an minus 1. So that's the other way of generating this. I think that works. If we start at the first term's 1. So 2, that'd be 4 minus 1 is 3, plus 1 would make 4. So yeah, that starts to generate it. So anyways, this is the recursive formula. This is the more simplified version of that. Okay. So anyways, there's all kinds of patterns that you can do. But there's two in specific. Well, let's hold on. I'll think of another pattern. Give me a second. This one's an easier one. Didn't say it's easy, I just said it's easier than some of the ones I could come up with. So that's the pattern. Can you see what the pattern is doing each time? Add halves. Okay. So if you were to come up with a formula for this one, here's the easy way of this one. And eventually you're going to learn how to do this. That's that formula. That's that equation. Okay. So if you wanted to find the 10th term, you could just plug in 10 for n, and that will generate the 10th term. Okay. So half of 10 is 5, plus 1 half is 5 halves, which is 5 and 1 half, 5 and 1 half, which is 11 halves, or 5.5. But now here's the next part that I wanted to explain, is some different notation. It's this guy. So that little capital E looking thing. You remember from your spreadsheet class, when you talk about spreadsheets and computers, what that means? So that's the sum formula. So that means you're going to add all the terms together. So that's the sum. So now if I do this, let's just keep it 1, 2, 3, 4, 5. I have 7 terms up there. So this is going to say I'm taking the first 7 terms that are generated by this equation, and we're going to add them together. Does that make sense what that means? So that means you're going to take this equation, which is the one we have over here. You're going to generate the first 7 terms, then add them all together, which 1, 2, 3, 4, 5, 6, 7. It's already done for you. You're going to add them all together. So 1 plus 2 is 3, plus 3 more is 6, plus 4 more is 10. So that's all the whole numbers. And then 3 halves and 5 halves is 8 halves, plus another 7 makes 15 halves. So if I converted 10 into halves, that'd be 20 halves. So 20 plus 15 is 35 halves. So that would equal 35 halves. So normally when they do this, they'll have like n equals 1, so you know where to start. Or sometimes they'll use i's equals something, like I equals 1 to 10 or something, then they'll have the formula I squared. So you just generate all those terms and add them together. So they'll have a variable on the bottom saying, here's what the variable is, and we're going to go from that. Do you guys know what the exclamation mark means in math? So it's called factorial. So that's the name of it. Your calculator will do it for you, but I won't teach you how yet so that you understand what your calculator does. So 5 factorial means you go 5 times 4 times 3 times 2 times 1. So the exclamation just means you take the number that you start with and multiply it on down. So that would be 5 times 4 is 20, times 3 is 60, times 2 is 120. 0 factorial is defined as 1. I don't know how that works, but that's how it works. So here's another problem with n's. Let's do this one. N plus 2 factorial divided by, let's do this. This one's going to be a little bit crazier. N minus 1 factorial and n plus 3 factorial. So if you're confused before, we'll make it worse. So go back to, if I have 10, what's the next number you multiply it by? 9, which is 10 minus 1. That's 9. The next number you'd multiply by is 8, right? Which is how much less than 10? 7 is 3 less than 10. So each of these we're going 10 minus 1, then 10 minus 2, 10 minus 3, right? And we'd go all the way down until there is 10 minus 9, which would be 1, right? Because 1's where we stop. So now on the top you have n minus 1 already. So it's like we're starting right here at 10 minus 1. So the next one would be 10 minus 2. So on this n minus 1, we're going to go n minus 1 is the first term. 1 less is n minus 2. 1 less than that is n minus 3, all the way down to 3 times 2 times 1. So that's just this first one. So now I start with n plus 2. So this is just an example, like if n were 10, this would be 10 plus 2, right? Which would be 12. And the next number would be 11, 10, 9, and 8. And so they're going down. 11's 1 less than 12, right? So my first number is going to be n plus 2. The next one is 1 less than that. What's 1 less than n plus 2? 11 on this, which is plus 1. It's 1 less. So this one was adding 2 on, and 1 less than adding 2 is just adding 1. What's 1 less than just n plus 1? Just n. Now what's 1 less than that? And so forth until we get to 3 times 2 times 1. So now on the bottom, we start with n as my first term. So the next one is what's 1 less than n? And 1 less than that one is n minus 2. And they keep going on down into, yeah, realistically, you just need the first one and the next two to get the idea. Yeah, so at least 3. And then the next one we start with n plus 3, right? So n plus 3, what's 1 less than 3? N plus 2, and n plus 1, and n. So now that we've got the fraction stuff done, right? You can cancel. So n plus 2 goes away with n plus 2. N plus 1 goes away with n plus 1. So everything here below is going to go away with that stuff. And n minus 1 goes away with n minus 1. N minus 2 goes away with n minus 2. N minus 3 goes away with n minus 3. And those all go away. So what's left? So on the top is 1 on the bottom. And that's your answer. So that's the factorial idea. It's the crazy stuff. You'll see the same idea with this, like 25 factorial times 23 factorial all over 26 factorial times 21 factorial. So now that you've got the idea in your head, I should have done this starting. 26 factorial is really 26 times 25 times 24 on down, right? So what's going to happen to all these numbers after 26 with this 25? Yeah, because that's 25 times 24 times. So these all go away. 23 factorial is 23 times 22 times 21. So once I hit the 21, all of this down here goes away with all of that. So I'm left with 23 times 22 all over 26. Okay. So that's what you just did with all the and stuff. So here's the problems then. So there's the problems. How many is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Oh, that's not bad. They aren't near as long as last chapter.